Hi, in this video I am going through the Week 4 poll for 2024 spring semester for my class. In this poll we discuss various functions related to data cleaning, and then we dive a little bit more deeply into regular expressions. So with that, let's just jump in. The first question is having you explore properties of common functions used in data cleaning. One of these is one of my favorites, and that is table. And what table does is it goes through a set of data, so you give it a single argument, and it counts how many of each unique value is present. And it actually returns a vector. That vector has the numbers as its values, so how many of each of those unique values. And then interestingly enough, the names of the vector are like attributes of the values, and they describe what those unique values were. And so what's nice is you can sort it as if it's a number, but since it's named, those names travel with it. And so this allows you to really explore these unique value counts, which is really useful when you're doing just various analyses. I use it all the time. So it provides a vector of positions that could be used to sort the vector. That's not anything to do with it. That is, in fact, an order. So an order function, it's a lot like sort, but it's kind of an indirect step. Instead of doing the sorting for you, it generates a vector that can be used to do the sorting. So it's this indirect step. And what that enables is these indirect interactions where you can take a data frame and then you can find like what should be the correct order given multiple arguments. So you can do like kind of subsetting of different ways of sorting data, and each of those arguments gets sorted in order, and then it produces a vector that can be used to do the reordering. So that's why it's this one. The one that a lot of students will have picked is returns a reordered version of the data, and that's not what order does. Order doesn't reorder the original data. The data it returns is actually just a bunch of integers because it's positions that should be extracted. Sort, in fact, is the one that does reordering. It takes the data, it sorts it, and it returns the sorted data. But that is a very simple interaction. It doesn't allow for multiple things. It doesn't allow for these indirect reorderings to occur. So you will see I actually use order most. I use sort a lot when exploring data, but if I need to actually manipulate data and change the order, I'm frequently using order because it allows me to do those indirect comparisons. Unique is just going to find the unique values. It doesn't count how many, it just tells you the unique values. So essentially this is the names of this object, whereas this has values that unique never sees or determines. Grep, grepl, gsub, and equals equals. Grep is a function that returns positions based on if it had a match to a certain pattern. That pattern does not have to be the whole value of the data that it's matching with, so that's a form of partial string matching. Grepl and gsub both do partial string matching as well. Equals equals only does whole string matching. Of these, the only one at all that returns a vector of positions, though, is grep. Grepl returns trues and falses. Equals returns trues and falses, depending on if there is a match. Gsub returns a modified version of the x argument. It's the only one that returns data that looks like the original object, assuming the original object wasn't like a logical vector. Yeah, grep is not going to be applied there. Gsub takes a data, it finds matches, and it substitutes in a replacement for those matches. So it allows you to substitute in new text. Very handy, very powerful, and it allows you to kind of modify the original argument. So if I put something in, the object coming back out is going to be the same length as it originally was. So that's why I say it's like a modified version of the x argument. Finds matches based on just parts of the compared values, so it's a partial string matching. That's going to be all of our regular expression using tools. Equals equals, on the other hand, finds matches only on the entirety of the compared value. So I think my wording here may have thrown people off, but I'm referring to the fact that equals equals, it has to be exactly the same. So this is a form of whole string matching. One string has to match exactly another string to return true. Or maybe false, but it's going to look at the whole string. Whereas these other three can look at parts of strings. They can return a match even if only part of the string matches the pattern. And finally, regex is going to be the same thing as that partial string matching. Regex is just the name for this little tiny language that we use to code in patterns. Okay, let's look at a couple of examples of these. Here I am taking some character vectors, length 1, using combine to make them into a length 2 character vector. So there's a character vector. I am then taking that character vector. I am identifying underscore dot asterisk. So this is a underscore followed by any character, any number of times, including 0 times, and replacing it with nothing. So applied to this one, what you would see is that this is a match, and then 1 is any character, 2 is any character, 3 is any character, 4 is any character, and a total of 1, 2, 3, 4 is between 0 and any number. Which sounds a little bit silly, but that is kind of the logic that you apply to this. So everything from here over would be then replaced with nothing, leaving you with CHR3, and that's it. For this, and the same thing applies here. So it would match here, it would extend all the way out forever, and then be replaced with nothing. So CHR16. On the other hand, vec2, I actually use these like lines of codes are just all throughout my scripting because I use this kind of syntax for snip markers a lot, and that's what I primarily work with, are snip markers. And in this situation, we are detecting a pattern that starts with any character any number of times, but then ends in an underscore. So any character, 1, 2, 3 times, 4 times, and then an underscore, that's a match. That's going to get replaced with nothing, leaving you with 1, 2, 3, 4. The same process is going to occur over here. Any character, any number of times, including 0, and then just a regular old underscore. So those are all going to be a match right here. And then that's going to be replaced with nothing. That's going to leave you with these kind of holding, vec1 holding on to the chromosome descriptors, and then vec2 holding into the position descriptors, except these will still be in the form of a character vector. So these are all character vectors. None of these are numeric vectors. Able to be coerced into a numeric vector, 2. If you try to coerce vec1, it's going to say in A because it can't turn CHR3 into a number. And if you try to do that to marker vec, the exact same thing happens. Represents chromosome and position values, represents the chromosome values only, represents the position values only. I do this because this is a very common implementation of these techniques. I use them all the time. You will see them in your homework. If you work on this type of data, this is the common type of G-sub that you're likely to need. This conceptual question is just trying to get you to explore this concept of like, when should we use one over the other? And like as a rule of thumb, and it's just a generality, grep and G-sub should probably be more used for exploring data and maybe manipulating data, but generally probably for the purpose of exploring it. If I'm then trying to put together a script file, like a long script file that cleans any sort of input the exact same way each time, which is how I should probably be structuring any attempt to clean data. That way it's replicable, it's scientific, it's good science. I will generally be using whole string matching. And that's because of stuff like this. So here I've given the example that LUE, when grepped, will pull up both blue and light blue. So that's great for exploring. If I want to know, all right, what people mentioned blue at all, I'll use grep and I'll look for LUE. I think the example I used in class is Mario Kart. A lot of people vote for Mario Kart for their favorite video games, but nobody spells it right and nobody capitalizes it consistently. So there's usually like 4 piles. There's Mario Kart spelled with a C, there's Mario Kart spelled with a K, and then there's usually some mixture of capitalization in there. Well, if I search for Ario, ... so that's space, and then either K or C, art, that finds everyone who says Mario Kart without relying on the fact that people misspell these things sometimes. So that's actually an example where I might go through and look for examples of people using a pattern as an exploration. But then if I want to actually go in and change the value like permanently, I'm generally going to be using a equals equals with a set value and replacing it with a set value. That way there's no ambiguity. If someone said blue, it should be replaced with blue. But if someone said light blue, it shouldn't also be replaced with blue. And if I had assigned, blue to anything from this extraction, that would have overwritten light blue. That's what I mean by dangerous. It could possibly destroy data that I didn't intend to destroy. So this one's a little bit tricky. The main issue is that I am trying to remove only the chromosome indicator. This is actually some descriptors, kind of like what was in your original variant data set. I think I made this particular issue a little bit easier for you by splitting them up, but in the original data set, sometimes you had these descriptors that were the chromosome, the starting position, and an ending position. And that's probably just because my manipulations, this is a very common thing I do, just because I'm somewhat good at GSub at this point in my life. However, for you guys, the challenge ends up becoming, how do I manipulate data in the presence of these multiple delimiters? Well, the trick, and it is just a trick, is that if you are trying to do an extension, so say like, all right, I'm going to start with CHR, and then I'm going to allow for any character any number of times, including 0, without the question mark, it will extend as far as possible. So it would go all the way down here without that question mark. But with the question mark, you trigger lazy behavior. And that means it stops here. And that's the desired behavior. So that's why the correct choice is that one right there. So hopefully that helps. Thanks for your attention, and let me know if you have any questions.